Take one.
Practice number 1. Hi, my name is Raghav and the topic I've chosen for this science fair is Archimedes' principle. Why I chose this project is because when I was swimming in my pool and got out, I felt a lot heavier, and when I went back in, I felt a lot lighter, and I wanted to know why this was happening. And I realized this was all explained in Archimedes' principle, which states, when a body is immersed fully or partially in a fluid, it experiences an upward force which is equal to the weight of the fluid displaced by it. And now I'm going to demonstrate Archimedes' principle. So I have a sandbag and a spring balance. And if I weigh this object, it shows 2 Newton, which is equal to 200 grams. And now, when I put it in water, it goes down to 0.8 Newton, which is equal to 80 grams. And the weight of the sandbag inside the water decreased due to the upthrust force or the buoyant force. And to find this buoyant force, we need to subtract the apparent weight, which is the weight inside water, from the real weight, which is the weight outside water. And if we do this, we will get 120. And now we are going to measure the weight of the displaced water. So it weighs 300. It says 182. And if we subtract these two, we will get 118, which is approximately 120. It is not showing 120 and it's showing 118 because when it actually displays some of the water is actually sticking to the jar, which causes a 2 gram error. And now, why did Archimedes come up with this problem? Well, there's an interesting story behind it. Once upon a time, there was a fellow named Archimedes who was born on 289 BCE in Syracuse, Sicily. One time, the king asked his goldsmith to make a crown for him, and when it was done, the king suspected that the goldsmith has used a little bit of silver and the crown was not made of pure gold, but the king could not prove this. So he called in his most intelligent scientist, Archimedes, to help with this problem. But there was a catch. Archimedes could not damage the crown whatsoever because it was the king's crown. Thinking about this, at first Archimedes did not know how to solve this problem. So thinking about this, he went to take a bath in a fully filled tub. And when he climbed into the tub, some of the water was overflowing. And he also realized that the more he went into the tub, the more water was overflowing. After realizing this, he jumped out from his tub and ran out in the streets shouting, "Eureka! Eureka!" which in Greek means "I have found it." And what did he find? He found the answer to the king's problem. Well, all Archimedes needed to do is get a lump of pure gold and get the crown and put them in 2 different jars and see how much water they displaced. If they displaced same amounts, then the goldsmith was not cheating. But if they displaced different amount, then the goldsmith has cheated. But what if the goldsmith has used 10% silver? Then it will be too hard to notice the difference between the two displaced waters. So that's when Archimedes came up with a brilliant idea. But I actually don't have a gold crown, and a lump of pure gold. But I have two objects that weigh the exact same. I have a rice bag here and a sandbag. So, and if I put this in air, they are equal. And when I put both of them in water, since the sandbag has a higher density, it sinks. While the rice bag, which has a lower density, will stay afloat. Similarly, the rice bag was the gold crown, which was afloat, and the lump of pure gold actually sank first, proving that the goldsmith has cheated. And that's how Archimedes' principle was created. And when we talk about Archimedes' principle, it's all about buoyancy. And when we talk about buoyancy, the first thing that comes to our mind are ships and how do ships float. Well, ships are designed in such a way to displace a lot of water that is higher than its weight. And also a lot of the ship's lower part is actually hollow, which decreases the density. Plus, a ship's bottom is actually having a curved bottom for it to not tilt side to side and help it go in a straight direction. Thank you.